3 days after it ended, you woke up with a sore throat. Not the kind that comes with a cold you saw coming. Not the scratchy warning after being out in the rain. This one arrived out of nowhere. By the afternoon, your whole body ached. Your joints felt stiff, your head was pounding, and there was this deep bone-level exhaustion that no amount of rest could touch. You thought maybe it was a coincidence, bad timing. Maybe you caught something at work. Maybe your immune system just picked the worst possible week to give out. But somewhere in the back of your mind, a quieter thought lingered. This started right after they left. This started the exact moment everything fell apart. People around you would say it's stress. That's the easy answer, the comfortable one. You're just run down because you're going through a lot. They'd tell you to eat better, sleep more, take some vitamins. Some might even say it's psychosomatic, a polite way of saying it's in your head, that you're so focused on the emotional pain that your body is mimicking sickness out of some kind of sympathetic drama. That explanation sounds reasonable. It also happens to be dangerously incomplete. Because what's happening inside your body after a heartbreak isn't imitation. It isn't metaphor. It isn't your mind playing tricks. It is a real, measurable physiological cascade that begins in your brain and radiates outward into every major system in your body. And science has been documenting it for decades. In 2011, a research team led by Dr. Ethan Kross at the University of Michigan published a study in the Proceedings of the National Academy of Sciences that delivered one of the most striking findings in modern effective neuroscience. They recruited 40 participants who had recently gone through an unwanted romantic breakup and placed them inside functional MRI scanners. Each participant was shown a photograph of their ex-partner and asked to focus on the rejection they experienced. Then, separately, the same participants were subjected to a controlled heat stimulus on their forearm, enough to cause genuine physical pain. The results were remarkable. The regions of the brain that activated during the physical pain and the regions that activated during the emotional pain of rejection overlapped almost perfectly. We're talking about the secondary somatosensory cortex and the dorsal posterior insula, areas that until then were believed to be exclusively involved in processing physical sensation. This wasn't symbolic. This wasn't emotional coloring. The brain was processing heartbreak using the same neural architecture it uses when your body is actually being hurt. And if this already has your attention, if you're starting to realize that what you went through might have been far more real than anyone gave you credit for, then stay with me, subscribe, drop a like, and don't leave before the end, because what comes next might be one of the most important things you learn about your own body this year. But here's where it gets really interesting. The psychological layer of heartbreak goes beyond just feeling sad. When a significant relationship ends, the brain undergoes something researchers have compared to withdrawal. Dr. Helen Fisher, a biological anthropologist at Rutgers University, conducted brain imaging studies on people in the early stages of romantic rejection and found intense activity in the ventral tegmental area, the same region that lights up in individuals experiencing cocaine withdrawal. The neurotransmitter at the center of this is dopamine. During a relationship, your brain builds a reward circuit around the presence of your partner. Every touch, every message, every night spent together reinforces that circuit. When the person disappears, the supply is cut off abruptly, and your brain doesn't gently adjust. It panics, it craves, it sends distress signals that manifest as obsessive thinking, insomnia, loss of appetite, and that unbearable pull to check their social media at 3 in the morning, even though you know it will destroy you. You're not being weak. You're going through neurochemical withdrawal from a substance your own brain manufactured. Now move to the chemical layer, because the damage doesn't stop at dopamine. When the brain registers the threat of abandonment, it activates the hypothalamic pituitary adrenal axis, the same stress response system that fires when you're in physical danger. Cortisol floods your bloodstream, adrenaline surges, your heart rate increases, your blood pressure rises, your muscles tighten. In short bursts, this response is protective, but heartbreak isn't a short burst. It's a sustained siege. Days turn into weeks, the cortisol doesn't drop, and when cortisol stays elevated for prolonged periods, it begins to systematically dismantle your body's defenses. It suppresses the production of lymphocytes, the white blood cells that fight infection. It disrupts your gut lining, which houses roughly 70% of your immune system. It impairs your ability to enter deep, restorative sleep. So when you got that sore throat 3 days after the breakup, it wasn't coincidence. Your immune system had already been quietly weakened from the inside, not by a virus, but by grief. And then there's the evolutionary layer, which puts all of this in a light that is both clarifying and deeply unsettling. For most of human history, being pair-bonded wasn't just emotionally convenient, it was a survival necessity. Two adults together could share the labor of finding food, defending territory, raising offspring, watching for danger at night. Losing a partner wasn't a romantic inconvenience, it was a threat to your continued existence. The brain evolved to treat the loss of a bonded partner as a category-level emergency, something that required the same full-body alarm response as being injured or cornered by a predator. That's why heartbreak feels like dying. Because a very old part of your brain genuinely believes that's what's happening. Now here's something that sounds almost unbelievable. You can actually die from a broken heart, not poetically, medically. It's called Takotsubo cardiomyopathy, also known as broken heart syndrome, and it was first identified by Japanese researchers in 1990. It occurs when a sudden surge of stress hormones, primarily catecholamines like adrenaline and noradrenaline, overwhelms the heart muscle, causing the left ventricle to balloon outward and temporarily lose its ability to pump effectively. The shape the heart takes during this event resembles a Japanese octopus trap, which is where the name Takotsubo comes from. For years, cardiologists assumed this was extremely rare and mostly benign. But a comprehensive study published in the Journal of the American Heart Association in 2015 revealed that Takotsubo occurs far more frequently than previously estimated, and its complications can include heart failure, dangerous arrhythmias, and in some cases, death. The most common trigger reported? Emotional loss, the death of a spouse, the end of a long relationship, a devastating betrayal. The heart didn't just feel broken. It physically changed shape under the weight of what the person was feeling. Your chest pain after a breakup isn't imagined. Your pounding heart, your shortness of breath, your feeling that something is genuinely wrong inside your ribcage, those sensations have a physiological origin. The emotional storm doesn't just pass through your mind. It lands directly in your chest cavity and remodels the organ that keeps you alive. And I want to take a moment here, just a brief one. I know this narration uses an AI voice, but behind every word, there is a real person. My name is Fernando, and I am truly grateful that you chose to spend this time here. I hope that whoever you are, wherever you are eternally blessed. Now let's go deeper. The inflammatory dimension of heartbreak is one of the least discussed and most consequential. Researchers at the University of California, Los Angeles, led by Dr. George Slavich, have spent years studying how social threats translate into biological inflammation. Their work shows that the brain treats social rejection and loss as a form of tissue damage, not metaphorically, functionally. The same pro-inflammatory cytokines that your body releases when you cut your hand or catch an infection, molecules like interleukin-6 and tumor necrosis factor alpha, are also released in elevated amounts following intense emotional distress. This inflammatory response is intended to be temporary, a short-term immune boost to help the body recover from what the brain perceives as a wound. But when the emotional pain persists, so does the inflammation. And chronic low-grade inflammation is not a minor inconvenience. It is now understood to be a foundational mechanism behind cardiovascular disease, autoimmune disorders, metabolic syndrome, and even depression. Your breakup didn't just make you sad. It set off an immune response that, if left unchecked, could reshape your long-term health. The ache in your muscles, the fog in your head, the heaviness in your limbs, none of that was imaginary. Your body was inflamed. Literally. There's also the gut connection, which most people never consider. The enteric nervous system, sometimes called the second brain, contains over 500 million neurons lining your gastrointestinal tract. This system is in constant communication with your central nervous system via the vagus nerve. When heartbreak triggers a cortisol flood and a sympathetic nervous system overdrive, one of the first systems to be disrupted is digestion. You lose your appetite, or you can't stop eating. Your stomach churns. You might develop nausea, bloating, cramping, even diarrhea. This isn't anxiety performing a trick. This is your autonomic nervous system reallocating resources away from digestion and toward survival. Your gut microbiome, the trillions of bacteria that influence everything from nutrient absorption to serotonin production, is directly affected by stress hormones. Research published in Psychosomatic Medicine found that individuals experiencing acute grief had measurably altered gut bacteria profiles within days, shifts associated with increased intestinal permeability, sometimes called leaky gut, and reduced production of short-chain fatty acids essential for immune regulation. Your stomach didn't just feel upset because you were sad. Your microbiome was being restructured by your emotional state. The breakup wasn't just in your heart. It was in your gut, literally reconfiguring the bacterial ecosystem that helps regulate your mood, your immunity, and your ability to absorb the very nutrients your body was now desperately needing. Sleep, too, becomes a casualty, and not in the way most people assume. It's not simply that you lie awake thinking about what happened, though that certainly occurs. The neurochemical disruption following heartbreak directly interferes with your sleep architecture. Elevated cortisol suppresses melatonin production, making it harder to fall asleep. But even when you do sleep, the quality is compromised. Studies using polysomnography have shown that individuals going through acute emotional distress spend less time in slow-wave sleep, the deepest and most restorative phase, and more time in light or fragmented sleep stages. This means even if you're in bed for 8 hours, your body isn't getting the repair it needs. Tissue regeneration slows. Memory consolidation suffers. Emotional processing, which depends heavily on REM sleep, is impaired. So the very mechanism your brain needs to work through the grief is the one being sabotaged by the grief itself. It's a devastating feedback loop. You need deep sleep to heal. The heartbreak prevents deep sleep, and the lack of healing deepens the heartbreak. So what do you do with this? How do you reverse a cascade that your own body is running against you? The first and most important step is recognizing that this is real, that the fatigue, the sickness, the fog, the chest tightness, the gut problems, the inability to sleep, these aren't signs of weakness. They are signs that your body is doing exactly what evolution programmed it to do in response to the loss of a bonded connection. You are not broken, you are activated. And that distinction matters enormously because what you do next determines whether this response becomes a temporary emergency protocol or a chronic disease trajectory. Movement is one of the fastest ways to begin interrupting the cycle. Physical exercise reduces cortisol, increases endorphins, stimulates the production of brain-derived neurotrophic factor, which supports neuroplasticity and emotional regulation. Even a 20-minute walk has been shown to significantly reduce levels of inflammatory markers in the blood. You don't need a gym membership or a marathon. You need motion. Your body is stuck in a freeze response, a conservation mode inherited from ancestors who needed to lie low when separated from the group. Movement is the biological signal that tells your system the danger has passed and it's safe to come back online. Social connection, even small doses, also sends a powerful countersignal. A conversation with a friend, not about the breakup necessarily, but about anything real, anything that makes you feel seen, triggers oxytocin release and lowers amygdala reactivity. The brain doesn't need you to replace the lost partner. It needs evidence that you are not alone, that the tribe still exists, that you still matter to someone. Even brief, warm interactions begin to recalibrate the threat detection system that heartbreak set to maximum alert. And here is where we return to that morning. You woke up with a sore throat 3 days after they left. You thought it was bad luck. You thought it was stress or a bug, or maybe just your body picking the worst possible moment to fall apart. But now you know what actually happened. Your brain detected the loss of a bonded partner and interpreted it as a survival-level threat. It activated your stress axis, flooded your system with cortisol and adrenaline, suppressed your immune system, inflamed your tissues, disrupted your gut, sabotaged your sleep, and left your body in a state of chronic emergency. You weren't just heartbroken, you were under biological siege. And your sore throat was the first white flag your immune system raised because it had already been fighting a war on a front it never saw coming. That knowledge doesn't erase the pain, but it transforms it. Because when you understand that your body is responding to a real threat with real mechanisms, you stop blaming yourself for not bouncing back fast enough. You stop calling it weakness. You stop pretending you're fine when every cell in your body is telling you otherwise. And you start treating your recovery not as a matter of willpower, but as a matter of biology. You feed your body what it needs. You move when it tells you to stay still. You reach out when every instinct says to withdraw. And slowly, not all at once but unmistakably, you feel the systems come back online. Sleep returns, energy rebuilds, the fog lifts, the ache in your chest softens into something you can hold without it holding you down. You don't get over a heartbreak, you metabolize it, and your body has always known how, you just had to let it. If this changed how you understand something you've been through, leave a comment. I read everyone. Hit the like button if this hit close to home, and subscribe if you want to keep going deeper into the science of what you feel. Because in the next video, we're going to explore a phenomenon that almost everyone has experienced but no one talks about. The strange reason your body physically freezes in moments of extreme embarrassment, and what that reveals about a hidden survival circuit you never knew you had. You're going to want to see that one.